Welcome everyone to the HL7 open source tooling series. The purpose of this series is to create awareness and highlight communities of practice for open, modifiable tooling that FHIR standards developers and implementers can adapt to their context. Over the last several weeks, and for a few more, through a cooperative agreement with the Office of the Assistant Secretary for Technology Policy, a division of Health and Human Services, HL7 is hosting this open source tooling series on Tuesdays and Fridays at 10 a.m. Eastern. So we invite you to join our other sessions. All of these sessions will be recorded and available to you to review and share with your colleagues from the homepage for the event. We'll share all the recordings, slides, and any links that are referenced there. As we go throughout this presentation, there is a Q&A box that is open. You can put any questions you have in there, and the presenter will try to get to them as he moves through the different sections of the content that he will cover today. Also, if you need to clarify a question, feel free to raise your hand and we'll unmute you. FHIR's open license, diverse community, and rapid adoption are laying a new foundation for interoperable digital health innovations. With so much happening across the FHIR community, it can be hard to keep up with all of these recent developments. The open source software ecosystem provides a rich starting point for organizations new to FHIR, those with limited resources, or those looking to build their solutions on community-driven applications. So today we welcome Mr. Ewout Kramer from FHIRly, who has been part of the FHIR management group and an integral part of the FHIR community from the very beginning. And he's going to share FHIR.net SDK with all of you today. So welcome, Ewout. Thanks for being here.
Hey, thank you, Sandy. And yeah, welcome everyone. Both to you who are completely new to this community and those who might have seen before. I do welcome you, and I'm really excited to be able to participate in these open source tooling webinar series, especially because I know as well how hard it can be to join a new big community that's been there for a while. And you know, you can feel pretty lost in the beginning. So I'm really happy to tell you about what we have done in the open source for the .NET developers. So first off, before I start, I am happy to take questions at any moment. So there will be like the classic slide with questions at the end of this tutorial. But as I go through the things that I want to talk to you about today, it might sometimes make way more sense for you to put up your hand. So as Sandy said, she'll unmute you and just post your question as you see fit. We should have enough time. Famous last words. Okay, so I am going to talk to you about FHIRly's FHIR.net SDK. And so that's basically everything we've built for the .NET developer for working with FHIR. Now, who's we? Who am I? Let's start with let's start with that first. So my name is Ewout Kramer. I am from the Netherlands. That's where I'm talking to you from today, from Amsterdam. And I'm the CTO at a company called FHIRly. As you can guess from the name, we are creating FHIR products, and we are using a .NET. We're a .NET shop, so we are developing in .NET, and the .NET API has a natural home at this company, but I'll tell you about that more later. So I am one of the main .NET SDK maintainers of the repository. We are 3 people within our company, totally dedicated to maintaining these tools. And I am also author of the FHIR standard. So I've been, as Sandy said, I've been involved with FHIR for quite a while. For this presentation, I tried to look back, but my first commits are somewhere in 2011. So that's longer ago than I would actually care to know. It's been a while. So what is the FHIRly.net SDK? Now, you know, in one short sentence, it is obviously something we made for .NET. So this is for .NET developers. So if you are a Java developer, you should have been here last week when James told people about the Java side of things. But today it's for the .NET developer. So it's a set of .NET libraries to help you work with FHIR. in a conformant way. That's what I'm adding. And the reason I am saying that is because, of course, if you read the specification, if you read the FHIR specification, it's grown quite a bit since we started it. There's a lot to read, that's A, and there's a lot to forget to implement. And so we have developed this library for you to get an easy start working with FHIR. In this case, that means, lay in contact with a FHIR server. Maybe you are developing a FHIR client, a .NET FHIR client. You want to talk to a FHIR server. You want to get the data across. You want to validate the data. You want to do things with that data. That's one of the first things everyone wants to do when you're working with FHIR. Of course, there's also people who want to write .NET FHIR servers. That's another thing entirely, but most people are consumers and they write FHIR.NET clients. So this library helps you get these first steps done. And as I say here, there is nothing there that you couldn't do yourself. I mean, I love reading specifications, and my hands would be itching to, always when I read a spec, I'm like, oh, I could write that, and you could, and people do. But there's a lot of things you can forget, and there's a lot of things you make. And if you do those, you probably wouldn't be conformant. So you might be talking to a server, sending it data, and it won't work because you're not sending it the right way. And you'll basically miss out on all the connectathon experience that we've had since 2012 and all the tests done by the thousands of users. So the repo has been forked many times. It's well tested by now. So yeah, that's what we're aiming for. And by all means, if you want to do it yourself, go. And that's always nice to do. But there's just tons of details. I mean, I can share you a little bit about those details and a bit of history. I think that's fair. Connectathon 1, that was the first time our my .NET code actually talked to other code, was in 2012. Now, what you have to realize is that we started writing the FHIR specification in, I think, somewhere 2011. And one of the things we wanted to make sure is that everything we wrote down in the FHIR specification was implementable. So in the beginning, it was Graham and I, the only two developers, software developers, involved in writing the FHIR specification. So Graham, as soon as we wrote a bit of the FHIR specification, Graham wrote it in Delphi, I think, and Java. James wasn't there yet. And I wrote it in .NET. And we would get together and say, okay, I tried to implement what we wrote down in the specification last week, and that didn't work. It was way too hard, or it's not practical, or and so on and so on. And after we'd done that for a year, we said, why don't we invite people to a first Connectathon? And that was the one. It's in Baltimore, I can see here, into 12. And then you discover how much details there are. So that's what that's what I referred to in the previous page. But if you like it, by all means, do it yourself. But we've discovered, like, dealing with byte order marks, getting the HTTP headers correct. There's so tons of stuff to do, and all that stuff is in the FHIR.NET SDK, ready for you to use. So you're invited to use it. And over the years, of course, the things in the .NET SDK have grown considerably. As I said, I was writing the .NET SDK as we wrote the FHIR spec. So we started with the essential things, which is, of course, the data types and the resources. Now, I'm assuming you know a little bit about FHIR. So the FHIR data model basically has resources. Those are the elements that you exchange, and data types. So the natural thing to do if you want to write the .NET library, and this is one of the main ingredients, I'd say, of the .NET SDK, is giving you POCOs for all data types and resources. And POCO is simply a class, a C# class that represents the patient. So if you look at the patient resource in the FHIR specification, all the elements there, like birth date and family names and all that stuff, it has an equivalent in a C# class that is in the .NET library. I'm going to use the word POCO a lot. I'm sorry, it's just, it's such a part of my jargon that I just want to make sure that you understand what a POCO is. It's a plain old C# object, derived from POJOs, plain old Java objects. So POCOs are basically the one-on-one classes that are in that SDK that represent the resources. So if you want to work with the patient data that you get, one of the things you do is we have parsers. So these take the XML and the JSON that comes over the wire, parse it in memory, and it gives you a C# class. So you have actually a patient object. So if you're asking a server for a patient, you're getting data back. The SDK will parse it for you, and you'll get in memory a POCO class, a C# class that is a patient. Works, by the way, I say C#, but it's .NET, so it works with F#. It works with BASIC and all the languages supported on the .NET runtime. So excuse me if I keep on repeating C# here. And then you can start manipulating the patient. You can start reading its field, manipulating it. And if you're ready to send something back, you can serialize it back out and send it back to the server. So the first things we started with when we wrote the .NET SDK and the Java SDK and any of those libraries is to get these data representations, these POCOs, and the parsers and the serializers. Now, let me see, answer live. I like that. Well, let's just test this system. I haven't done it. I get a question about, hey, I'm a new employee and I'm using the FHIR standards in Rhapsody. So how does FHIR communicate with Rhapsody? Well, there should be an easy answer. If Rhapsody has a FHIR interface, you can communicate with it. If it doesn't, FHIR doesn't communicate with it. The beauty of FHIR is that servers and clients can certify for it, and I mean can put a conformance on the website. And if they talk FHIR, you can talk to it, and if you talk to you can just the same way as you can talk to Epic. So the kind of software, in this case Rhapsody, shouldn't really matter. But of course, these companies need to implement FHIR first. So for a lot of companies who already exist and have existing databases with medical data, they normally provide a layer of FHIR functionality on top of their existing stuff. So if you were a Rhapsody developer, for example, and you're looking at this presentation, there are some things in the .NET SDK as well to help you get that layer on top of your software, but not a lot. As I said, we focus mainly on the client side. So if you're a client, it shouldn't really matter what happens on the other side, whether it's Epic or Rhapsody or Chipsoft or any other software maker. It should be able to talk to you. It's not always true. I do get a lot of, for example, bug reports on the SDK saying, hey, I'm talking with FHIR, using your FHIR SDK with server X, and it doesn't accept the data. And most of the time by now, certainly because the library exists for more than 12 years, it is because the server on the other side is not conformant. But of course, sometimes we do find a mistake. I hope that answers your question, and otherwise you can ask a new one. So I mentioned already a little bit, after we have all that, the next thing up in this structure is a FHIR client. So there's literally a class called FHIR client in the library, and this does the actual communication with the server for you. So this is from client to server. FHIR on the HTTP page in the FHIR spec has something like 10 to 20 operations, basic operations to get data across, to update data on the server, to search for data on the server, and so on and so on. And they are implemented one-on-one in this FHIR client. So if you combine the POCO classes, the serializers, and the FHIR client, this actually is a full story if you're a FHIR client developer to get data from a server, or to search data on the server, to update it and send it back. Maybe that's all you need. And in fact, I think for about 90% of the users of the FHIR SDK, these three components of the .NET SDK are just all they need. But we can go beyond that. So once we've written a part of the FHIR spec back then in 2012, when we got this done, that was phase one. Graham and I were like, so phew, we're ready, but we're not, right? One other important part of FHIR is once I get data, whether it's as a server or a client, I might want to validate it. And you might know from following FHIR tutorials or reading the spec that there are profiles. Profiles are basically validation contracts our validation contracts that like you have them for US core. If you most of you might get in touch with FHIR through an IG and implementation guide, and they will specify profiles. And profiles are sort of like constraints on the full FHIR spec that make it localized for a certain country or solution. Now, it would be nice if you could validate the incoming data against these profiles. So if you're using the US core IG, for example, you want to make sure that the data you're receiving actually complies to the US core standard. Now, to be able to do that, we need a few more pieces. And FHIR's metadata comes in NPM packages. So if you're downloading an IG for US core, for example, again, you're downloading an NPM package. So obviously, we build in functionality to access the data in such an NPM package. NPM is not a standard. I mean, it's widely used, but its owners and its authors never bothered to turn it into a standard. So we do provide functionality for you to open these files and look through FHIR things inside them. Now, I'm falsifying history a little bit here because FHIR packages and NPM packages are actually latecomers. Maybe we introduced them about 5 to 6 years ago. So the first half of FHIR's lifetime, we didn't have packages. We distributed the FHIR specification in a zip file. And if you're probably not if you're following this tutorial, but people who've been with the spec for a while know that these zip files were the only thing. And we still include support for reading those zip files, but you shouldn't encounter them anymore. And if you start a new application nowadays, don't bother. You start with these pieces. So, okay, that's nice. We have these NPM files. You need to be able to read and do something with these. These NPM stuff contains profiles, but also things called value sets, which contain terminology. And for working with that, we have functionality as well. So you can actually ask, is this ICD-10 code an allowed code in this field? Is this coded field, and so on? And that's all in terminology services. No, yeah. Good question. Are these NPM packages or NuGet packages? These are NPM packages. Yeah. So if this was a .NET only world, we would have distributed the FHIR specification as NuGet packages, but we are not. And so we chose NPM as the way to distribute the FHIR packages. Could we redistribute those as NuGets? I guess we could, but we would also always be lagging behind. So we build in support for reading NPM files. Good question. Terminology service, and there is another part of the FHIR library that's called the FHIR Path Engine. I can't go into deep what it's that, but that's basically one part of profiles is FHIR Path, which is kind of a constrained language, a kind of mini programming language in which you can program invariants, constraints, data validation rules. And we have that too, because then with all these parts, we have a thing called the validator. So the validator validates your incoming data against these profiles, these IG profiles and so on. And you need all these bits here, all these blue bits to get all of that done. So this validator sits at the top of the hierarchy, so to say, because it uses almost every single part of the rest of the SDK. And you need to get everything running to get the validator running. Now, additionally, recently we've added the CQL engine. And so that allows you to run CQL. If you don't know what CQL is, I can't go into that, obviously, but it's a clinical query language, and it will be used to encode quality measures amongst other things. This is a language in itself, and we've added, or we are adding at this point in time, capabilities to work with CQL. Now, each of these purple boxes here, that's just a practical thing, are distributed, and the dotted everything are distributed separately. So there we also have separate GitHub repos for them. So the blue boxes here are in one repo. The CQL engine has its own GitHub repo. The validator has its own GitHub repo, and the resolvers do have their own GitHub repo. So if you want to report a bug or work with us and do a pull request. And I have a slide later with the exact addresses of these repos. Now, you might ask, I'm focusing on FHIR client. Where are the server components? HAPI has them, but we don't. We did initially, because when we developed the FHIR standard, I also built server parts to test the server bits of the FHIR specification. But in the end, this branched off. So our company focused on making a commercial product. So what we did is we basically, so it's not part of the .NET FHIR SDK. We branched it off and we open sourced it. This was a separate code base called Spark. It's still there, obviously, but we don't maintain it anymore. And we donated that to the open source community when we started on our commercial offering called FHIR Server. Which means that the code's still there. It is being maintained. This is the Git repo. I think also in HL7's open source library, HL7 is keeping a library of open source tools for .NET as well. This has a separate entry. It is maintained by Kenneth Mira and by volunteers. So definitely help is appreciated there. It uses the rest of the SDK that I'm talking about, of course. But if you're familiar with the HAPI and you think, where are the server components from HAPI? They're not in the .NET SDK. They're in this separate repo called Spark. Here it is, Spark server. As you can see, it last update yesterday. It's definitely being maintained by its current maintainers and its volunteers. So take a look if you are looking for server components. One of the things you can find there is how you can, for example, write your .NET HTTP formatters to use the serializers and parsers, so to be able to receive FHIR data at the server side. As I said, we split off the commercial part and the open source part. So we do have a commercial part, which is called FHIR Server. That has commercial support. We focused for the last years on performance and security, the kind of things you don't normally immediately do with an open source effort. We added a lot of compliance to national regulations, but it is closed source. That being said, most important is it's used a lot as a test endpoint. It's here in the middle of the screen, https server.phir.ly. So it's one of the open test endpoints that you can test against. If you don't have anyone to talk to you yet, you're writing your FHIR client, you want to test what you're doing, https server.phir.ly is a 24/7 always running FHIR endpoint with some example data that you can freely write to. You can update whatever you want, you can delete whatever you want, play with it. That's one of the most important things about FHIR. It's not just a specification. There are these kind of test servers that you can test with, so you're not have to play privately at home. When you read the spec and you use the .NET SDK, you can immediately try it out with these open source or the open servers, and this is one of them. I shortly talked already about the POCO classes. Just to make sure that you know what we're talking about, this is a snippet from these POCO classes. They are generated. Let me tell you that. I'm not handwriting these things. The FHIR specification has about 120 or so, 120 or so classes, and it would be very error prone. So from the beginning on, we generated that. Actually, in the beginning, this is just a bit of history. It was part of the Java tooling. You might know that the FHIR specification itself is being generated with a big tool written in Java, and initially that Java tool also generated the C#. Well, I can tell you that was no fun. Writing in Java, generating C# code that I then had to compile in C# to find whether I made a mistake in the Java and back again. It was terribly slow. So at some point, someone from the community, Brian Postlethwaite, said, enough of this. I'll write some proper source generators. And so now we're generating these things in C#. So they're generated, and they come, as I said, they come with their own parsers serialized. The fact that I repeat that one more time is that the most frequently asked questions on our support mailing list is, can I use the standard system text JSON serializers? Can I use the standard XML serializers with the .NET spec? You can't. I'm sorry about that, but the JSON and XML serialization that we devised, I'm guilty of that too, but FHIR's JSON and XML serialization is complex enough that the standard serializers can't do it. While I'm saying that, I will confess that I have a slight, the kind of things you'll do on a Friday afternoon if no one's watching. I have seen system text JSON version after version of the .NET framework gets more and more powerful. So I am every time looking again on whether we can manipulate system text JSON to actually natively support the FHIR JSON serialization. It wasn't possible until now, but it gets more and more flexible by the version. So that statement, that might not be true forever. But for now, it comes with its own parsers and serializers, and you really have to use them. If you don't use them, you just don't get conformant XML or JSON. Another fact of life is the JSON serialization different from the XML serialization in FHIR? Oh, let me see. Answer live. I will answer this live. Well, obviously because JSON isn't XML, but it is reasonably one-on-one. It is so one-on-one that you can write a tool to convert between the two. So if you are familiar with the JSON serialization, you can read FHIR JSON and you can read FHIR XML, provided you can read XML at all, of course. I mean, XML is slowly dying, but yeah, so they share a lot of traits. We made them at the same time, and they contain the same data and they have the same structure. Nice. Oh, get my pen. All right, another fact of life that you have to know about when you're using with these libraries, there are multiple FHIR versions, R3, R4, R5, R6, R7, STU2, they have all names, and each FHIR release so far introduced breaking changes to the resources. So we had no other choice as to publish multiple versions of our SDK. So we do have an SDK for STU3, R4, R4B, and R5, and we're busy doing R6.1. And there are frozen dead things for previous ones like STU2. We don't maintain them anymore. I didn't put it on the slide, so you hear it from me directly. We don't maintain the STU2 anymore. I think we did an update, while I'm saying that we did an update not that long ago, because there was really a big mistake in it. We might do that. Someone brought a PR and we're like, okay, we have a ready-made PR. We'll pull it. We'll re-release it. But generally, no, we don't maintain it anymore. It has none of the new functionality. But we do maintain STU3 and forwards. This is in contrast to maybe if you know other packages like the Java one, which has one library with everything in it. For us, all the classes, like the patient class, are in the same namespace in each and every version. So there's not an R4 namespace and R5 namespace. So there is just one HL7.FHIR.model.patient. So if you want to use multiple versions of FHIR into a single application, you can. You link to multiple versions of these libraries, the multiple, and with something called in C# external alias, you can actually use them at the same time. I have examples of those. They're easy to find all over. I think we do have them in our documentation too. So you can work in one application with multiple versions at the same time, where we do publish a single version, multiple assemblies, post-fixed with R3, R4, R5 for all these different versions. Luckily, as HL7, as time progresses, more and more of these things stabilize, and we don't really need to make new versions of them anymore. So what we've started to do, we started to introduce, certainly for those like us who have to work with multiple versions of FHIR, we start to pull resources from all these different assemblies into a shared assembly called HL7 FHIR base. That contains everything that is shared from version 3 and later. And think about things like bundle operation outcome, all these foundational resources, they are there. The data types, they haven't changed in a long while, or they changed in a backwards compatible way. So we were able to put those in a thing called HL7.FHIR.base. And we have HL7 FHIR Conformance, which is all the R4 and newer stuff. So if you're working with R4 and newer, you can use HL7 FHIR Conformance, and there's a growing number of classes in those ones: code system, structure definition, capability statement, but not like patient and so on. All these classes are still, although some of them are normative, we don't have them in libraries that are shared across versions yet. And so there is HL7 FHIR SU3, 4, R4B, and 5, as I promised on the last slide. And these contain encounter, measure, medication, observation, patient, and all these other resources that are different per version. The SDK library also has code system, structure definition, and capability statement, because it doesn't take part in the conformance library. So conformance has R4 plus of all these things, and SDK library has its own incompatible version of code system, structure definition, and capability statement. This isn't nice, but this is a fact of life. It was called SU3 because it was it was a trial use standard, and I know we've written quite a bit of software in SU3, but it wasn't compatible with R4, and it's only probably starting from R6 that we're really going to see backwards compatible versions. So this picture, unfortunately for us software developers, will remain a fact of life for a while. Then I'll go over a little bit on the other parts. So we've dealt with the POCOs. I already told you about the profile validator. So the profile validator validates FHIR data against profiles from IGs. I said that before. These profiles can come from packages, directories, zip files, databases. We made the .NET SDK flexible enough that by implementing an interface, you can implement your own sources of profiles. So my colleagues of the Simplifier and FHIR server, they wrote their own implementations. So for example, the profiles don't come from directories or zips or npm files, they come from a database. And that's definitely possible. The validator returns operation outcome, which is a FHIR resource specifically made to communicate errors. So that's not a surprise. The validator returns operation outcome, and it's built for performance. Although it's currently under the covers, we'll open it up soon enough. Internally, we compile these profiles to some kind of intermediate format, and then we start validating. So if you validate multiple instances against the same profile, you get a speed, you get a performance gain, because we compile the structure definition once and then validate all the instances against that same structure definition. And also you can add your own custom rules at compilation time. You can influence the compilation process and add your own domain rules. The CQL engine, for those who know CQL, it allows you to evaluate CQL libraries. So that's libraries with measures and all kinds of quality logic, decision support logic. They are packaged in something called libraries. That's a CQL term. And we took the language specifications, the CQL language. It's a big language. It's a big query language. If you're interested, it's maintained just like the FHIR standard by HL7. So it's a sister standard if you want. And you can take these libraries and evaluate them against a bundle of FHIR data, these POCOs that I've been talking about, and it will return you the result of the functions in these libraries. Now, the tooling stack that we've built turns CQL into Elm, which is an intermediate languages for CQL. Has nothing to do with the .NET stack. It's an HL7 thing, and then we turn it into C#. And now it becomes interesting for us, of course, because then we can compile the C# and we create native .NET versions of these CQL libraries and functions. For those who are interested in CQL, it's just to make you to interested you in what we're doing there, you could turn CQL libraries into .NET assemblies and execute the CQL. Yeah, and we're busy finalizing version 2.0, which does have a CQL to Elm translator, which if you, this is donated. Yeah, that's an important point. That whole code, the CQL engine, is a devilishly difficult part of the SDK. We would never start such an effort, but large bits of this code have been donated to us by an organization called NCQA. you might know them, they publish HEDIS measures, and they do that in CQL. So they needed CQL engine, and they've published it for us. And so they donated the code, and now we are cooperating with NCQA to build that engine out and maintain it. This list isn't ready without mentioning Microsoft. I told you we're not handwriting the POCOs. In fact, I'm using a tool that's been written by Microsoft specifically for us at first, but it does way more now. So I am giving a kudos to Brian Postlethwaite and Gino from Microsoft, because they spent tons of time writing a tool that reads the npm packages of the FHIR specification and allows you to emit code not only in C#, but also like TypeScript. I know there's a TypeScript library generated. We use it also to generate open APIs, Swagger, all based on the FHIR definitions from these npm files. So we have our own fork of this tool, but we basically, together with Microsoft, maintain it. So you can run this tool as well, which is interesting because it means you can add your own POCOs. So if you've designed your own FHIR resource using this FHIR CodeGen from Microsoft, you could run that tool and create your own version of the .NET SDK with your own resources. Is the CQL engine part of the FHIR SDK? Yes and no. It is because we have updated, when we received that CQL engine, we have made sure that it supports the FHIR SDK's POCOs. So our patient classes, it works with our classes and it returns our classes, but it is a separate repository. And there are some long things to do to make these two code bases that have that started separately together. For example, we both have a set of basic data types and logic for working with intervals, date times, and so on. And we have two of those, one in the CQL SDK and one in the FHIR SDK, and then still have plans to unite those. But otherwise, they work seamlessly together. That's, of course, what we're making sure. When you start working with all this stuff, this beautiful stuff, we try to document a lot of it. So at docs.fhir.ly, you can find the documentation for the .NET SDK. Now, the writing documentation is no one's hobby and certainly not an open source project. But we do, I think, whenever we add something new, we document it. And that's another way to say that, well, we didn't before. The first 3 or 4 years or so completely in the beginning, I didn't bother writing documentation, maybe like any good new open source project. And so we have some history to clean out there. But I'm pretty happy with the state. It's also open source, so do a pull request if you add your own piece or find a spelling mistake. Next up. Yeah, overview. So of all I've said, here is a list and you'll get the slides. So here you have this nice table of all the parts, all the repositories that have been, there where you can find their open source code, the maintainers and their NuGet package IDs. This is for your reference. So you can easily find this after this presentation. Maybe it's nice to know a little bit what's next. We are currently working on version 6 of the SDK, which means we're now in version 5.10 actually. We are not often doing a major version. We take backwards compatibility seriously. So I think there is more than a year, maybe up to 18 months between major updates of the SDK. So we really try not to break stuff. Of course, the first ones to notice that we're breaking stuff are my colleagues itself. The SDK is used within FHIR for our simplifier product and our FHIR server product. So if we're breaking stuff, we hear it early. And since we have thousands of users, we do tend to hear if we're breaking things. But I think we're doing okay. We have Microsoft's binary backwards compatibility. We're not striving for binary backwards compatibility, by the way. but we do try to make compile compatibility work. So if you take a new minor version of our SDK, we do want you to be able to just hit compile and run. What are we working on in the new version of SDK? Well, some breaking things that we can finally do after 18 months. We will do some cleanup of the POCOs. We will add more better support for having your own custom resources and backwards compatibility, mostly encountering resources with new fields in it. And this is going to happen with HL7 FHIR 6 Plus, because there will be more and more resources that just add new elements. And so we want to make it easier to work with newer versions of version 6 of the FHIR spec without you having to for us to have to update the SDK all the time. So we're adding new textual rules to the validator. The current .NET validator mostly validates whatever is in the profile. There's tons of handwritten rules in the FHIR spec that we don't do. We're adding those. And as I said before, we are working on 2.0 of the CQL SDK, which would support CQL rules coming from CMS and NCQA, which is the HEDIS things. Can you point, I got a question here from Praveen. Can you point the .NET code generator from CQL, so CQL to Elm to C# code to another FHIR server and execute it? No, definitely not. Currently it executes on a bundle. So yes, you could, but you have to do the effort. You'll have to fetch the data from that other server into a bundle and then feed it to our CQL engine. It would be horribly inefficient. There's a lot to say about this. But one of the things to make a CQL engine performant is to make sure that you don't send it too much data. And that's hard. That means analyzing CQL queries and looking at what data is exactly needed by it and then only fetching that. Because the other side of the spectrum is if you don't know what the CQL is needing, you'll have to do a patient everything, which is a freaking big bundle of data. And you can do it. You can do patient everything in FHIR and ask all the data from the server and then send it to the CQL engine. That would work in theory, but it would be really, really slow. And that's all I'm going to say about this. I could fill another hour or two. But I also wanted to point you out to one of the most important things if you want to work with the FHIR .NET SDK and you need some example code to get you started. Well, the documentation is one. I showed you that one, but this is the other biggie. GitHub Firely team, the validation demo. This is a Windows app. Sorry, even if you're on a Mac, you might be able to run it, but then at least you'll be able to read the code. It's a Windows app that that allows you to paste in some XML or JSON, I think. Yeah, it does. And then validate that against profiles and show you the result. And the reason that this is a nice demo is because I said it slides ago, the validator basically builds on top of everything. So this demo shows you how to get to FHIR metadata, how to parse FHIR data, how to set up terminology services, and then combine that into a very useful thing, which is validating FHIR data. And you can find it here at this address. And let me now, I'd love to show you it. So I'll probably have to share a new window for that. I'll share my screen for a change. Share. So you should be able to see that I opened the link. And here is the profile validator. So I just have to ask Melinda now, is this readable? Can you people see this and in the presentation?
I'm seeing your slide.
You're seeing the slides. Okay. Let me check. You know what? I stop sharing. I say share. And I'll try again. Here, application windows. No, I want you just to see my screen. Oh, yeah. Share. Oh, I see what's going on. Excuse me. Wrong screen error. That's what you get with multiple screens. Probably we want to share this screen then. Now you can see a Windows app, I hope.
Yes.
Thanks. Good. So as I said, sorry, it's Windows. So on top here, just to give you an idea, I did supply a lot of data. There is also comes with the data. Maybe that's way more interesting to show some data with errors in it. So let me open that one. And it actually begins with what kind of errors you should see. And then if I press validate, I'll dump here all the errors that the profile validator found. It's a a user interface designed by a developer. It's me. I'm guilty. You can change the directory where you have your profile stored. It doesn't read packages for now, so you'll have to dump these profiles somewhere. It's very handy for us when someone reports a bug to us and says, "Here's a bunch of profiles. It doesn't work against them. We'll dump them in a directory and we just read them." You can select the terminology server to use. Though I have to be honest, when I tried that while preparing this demo, I saw that it didn't work anymore. We're working on it. So it works with our built-in terminology service, which is something that the .NET SDK has. That does most of the things you need, for example, for US Core. So the built-in terminology server is fine for tons of validations, and it does R4. So that's about it. And of course, the interesting thing is the code, not so much the thing. The thing has a main form, and all the interesting bits happen here. It actually starts out, so this is actually interesting. With the first line here creates a standard resolver, as we call it. So this is your access to FHIR's metadata. In this case, it's the standard R4 package. And if it can't find it, it will download it from an NPM server. So bam, we have that one. We better cache it because NPM is slow. And then I build a serializer, which I need to deserialize and serialize those XML and JSON bits there. And I do that with our FHIR serialization engine factory. All of this, by the way, is in the documentations that I showed you. It's just nice to see this working here. And I say I'd like a strict, I am strict, I'm a validator after all, I'd like a strict parser. There's also a parser called ostrich, which you can guess does the complete opposite. It allows almost any FHIR data to go to pass. And that's useful if you don't want to validate, but you just want to get the data in, even if the sending party made a mistake. It just tries to get any data that it can from the JSON and put it into the POCOs. But for now, of course, we're choosing strict. Other interesting things that I'd like to show you is that, as I said, it can read profiles from a directory on my disk. And this piece of function does that. Let me see what that is. You can see we have a thing called the directory source, and the directory source is something that reads profiles from disk. And remember, we had this core source, which is the NPM package. This, of course, has all the stuff published by HL7 itself. A directory source could have all your private profiles and things, and the multi-resolver then combines this. So this software will find first the things that you published in that directory, and if it can't find it there, it switches to the NPM package from published by HL7. Someone says that the attendee is not seeing the QA listing. Well, anyway, can you share the questions with us as the post resource? Yeah. Anyway, is there? Yeah. Generate snapshot is an interesting one. Profiles. Most of the profiles, I hope. Well, a lot of profiles are posted, including something called a snapshot. Profiles can have a light version and a heavy version. The light version contains just the things that the author of that profile wanted changed. Changed from the FHIR spec to this specific profile. But tools can't work with that. You need to generate a snapshot. Otherwise, you can't validate because it will only mention those few changes that the author, if the profile did. So you'll make a snapshot and then you can validate. And As you can see, I create a local terminology service here. So that's a thing that doesn't go out. We have support for external terminology servers that live on other servers, but we do have a built-in local terminology server that can handle a lot of FHIR terminology, as long as it's in the basic FHIR spec or in one of those directories that you provide to that source that I just showed you. And as you can see, depending on what I did in that drop-down box, we add an external terminology server and combine those as well. Now, in the end, after we got all that stuff, we parse the thing, and we call the validator. Let me see. We rebuilt the validator at some point. That's here. Rebuild validator. So we refresh the profile source, so that builds that resource resolver, with that multi-source and directory source and so on. We have a terminology service, and we combine all those things, and then I construct a new validator. And the validator needs this source to the specification data. It needs a terminology source. It allows you to provide a function that it can call if someone refers from your resource to an external resource to another resource, because FHIR is full of references. That function is called, and you can provide that resource. Sometimes you want to go out on the web, maybe it's in your database, whatever. And there's a few more settings. And then you go validate on this validator, and it returns an operation outcome. So that's just the basic ingredients of this demo tool. I think that provides a great starting point. So that's why I like to point you out that this is something you should probably look at. Now, let me try to get back to my presentation. So I'd like to share it with you again. Well, there we go. I hope you can all see the demo. Slides again.
Confirmed.
Confirmed. All right. Before we go to questions, I want actually this slide first, because today you're talking to me, but I'll be gone in a good 10 minutes. But that doesn't mean that you're all alone. We have this demo. You have I gave you the links to our open source repos, and we do have a discussion forum on github.com FHIR team net SDK discussions, and we do monitor that intensively. We monitor the discussions, we monitor the pull requests, we monitor the issues weekly, sometimes daily. I see them coming in daily. So we actually prioritize all the issues that we encounter, and eventually we deal with your stuff, especially if you're reporting a bug. Now, it would be entirely lovely if you would, and some of you do, provide us with the bug and the pull request. That does help speed up the process a lot. And if you want to participate, get to our repo and I want to do a pull request, get in touch with us first, because then we can discuss the kind of things you want to do. Maybe we're working on it as well. Maybe you have some ideas about how we want to integrate that. And it would be nice if we can have a discussion before, sometimes we had it, unfortunately, people do bringing us pull requests with days of work and we can't use it, which is unfortunate. So do know that we are actively maintaining it. Do know that if you participate, we are on the other side. We are in a different time zone if you're in the US, but we exist. Then we have on chat.phir.org with Zulip. And if you don't know what it is, this is not the place for me to show you around, but chat.phir.org is your essential ingredient to connect to the FHIR community. And we have our own .NET channel. And there's tons of .NET developers around that will help you on the spot with when you have a question. So this is something you should add to your repertoire of channels to navigate. And finally, there is my email address. And I'll be honest, I have so many inputs from Zulip and the FHIR SDK that email is my last priority. So you can send me an email, and you should if you have a big story to tell me. But I have more colleagues working on the .NET SDK, and it's best if you use Zulip or the discussion forums on on our repositories. So that brings me to any other questions that you might have.
Should be able to.
Yeah, Srinivasa, yeah, I have a lot of questions for about Rhapsody. So why don't we instead of typing, why don't we talk? That seems like a good idea.
Yeah, you should be able to unmute now.
I am able to unmute now.
Great.
Hey there, hello, welcome.
Hi, Ewout. I just joined the Rhapsody team recently, and I'm a new employee. So I just wanted to know, like, how does like the FHIR messages work with Rhapsody?
How I can answer is a little bit on depending on what you want to do. So are you, for example, your new function going to be responsible for giving Rhapsody a FHIR interface? Does it exist already? Or is there a FHIR interface for Rhapsody already?
So like we're already using an existing FHIR interface for Rhapsody. And we're trying to like interact with it. So that's what like I was going to ask.
Okay. So the FHIR specification actually standardizes all the operations you can do with a FHIR interface. So these are at least the simple things. So getting data, updating data, deleting data, searching data, and so on. All these things are very precisely described. So if a product like Rhapsody implements FHIR, most of the time it implements these operations. It doesn't have to implement all of them. For example, if the application doesn't allow a client to write or update and change data on the server, those operations are not implemented. But almost every server implements the basic get, HTTP get operation to get patient data, and they all do search for data. And these are exactly described in the FHIR standard. And the FHIR client that I told you about exactly mirrors those operations. So there's a read, there's an update. And so if you use those and you talk to the Rhapsody FHIR endpoint, you should be able to get data through that.
Okay.
Now, while we're at it, IGs, like US Core, can add additional operations. So the FHIR basic standard has a fixed set that most servers implement. And then depending on nationality, so for example, US Core adds additional operations. And so if the product you're working on is from France or Belgium or the Netherlands, where I'm from, it might all have those. And conversely, if you're trying to export a product from a US company to the Netherlands, you might find that you will have to add operations that are used in other jurisdictions.
Oh, and what are like the different like message types in FHIR?
I think, so most of the use have been talking about today is the RESTful part of FHIR. So FHIR defines these FHIR resources like patient and so on and so on. And these are all based on REST, so web technology, get, put, and so on and so on and so on. But FHIR also describes a messaging framework, and you might be referring to that. That messaging framework doesn't actually, so the FHIR RESTful framework really prescribes which operations exist. So you know they exist when you have a FHIR server, but this is not true for messages. So unlike with V2, where you had a ADT message, for example, this doesn't exist for FHIR. So you're totally dependent on implementation guides. So I know, for example, that in the UK, the government uses the FHIR of the messaging part of FHIR. So they have created their own localized UK-based FHIR implementation guide that details which messages must be supported if you're working in the context of UK healthcare.
Okay. That's all I had. Thank you very much.
That's easier than typing, right?
Yes, it is.
Okay, I think we're about out of time. Thank you, Ewout, for being here. We so appreciate you sharing your wisdom with the community as
You're welcome.
always. And thank you all for participating. And we will see you next time. Have a great day, everyone.
And maybe see you in the workgroup meeting in 10 days, 7
Yeah,
days.
here's hoping.
Yeah.
Safe travels. Bye-bye.
Bye.